find the mass and center of mass of a triangular lamina with vertices. So the vertices are 0, 0, 1 and 0, and then up here 0 and 5. So again, we want to find the first of all, we want to find the center of mass. Center of mass is going to be first of all, we want to find mass. So mass is going to be the double integral over the region of 1 plus y dA. So basically you go the tiny bit of the Robinson rectangles, and you multiply that by the mass, and then you add them all up with the integration. And so how do we set up this integral is I'm going to try to make it y simple inside. So y simple inside, and what I get is I have to solve for y, and this is the slope of this is the slope is 5 minus 0 over 0 minus 1, that's negative 5, and it goes through point 1 and 0, so it's negative 5 times m x minus 1, negative 5x plus 5. And so I solve for y, and that's the most inner, so it goes from what's the lowest curve, 0, and goes to negative 5x plus 5, and I have 1 plus y, and then the outer is going to be the x value going from 0 to 1, dy dx, integrate, it's y plus y squared divided by 2 from 0 to negative 5x plus 5, and integral from 0 to 1 dx, and then what you end up with is negative 5x plus 5 plus negative 5x plus 5 to power 2 divided by 2. And then integrate this from 0 to 1 dx. So I know the integral of the first part is negative 5/2 of x plus 5x, and then the second part is going to be negative 5x plus 5 to power 3 divided by 6 times negative 5, and we plug in 0 and 1, and so for 1 you get negative 5/2 plus 5 plus 0. For 0 you get 0, oh this is to power 2, you get 0, and then here you get 5 to power 3 over negative 5, so you get 25 divided by negative 25 divided by 6, so the entire thing is 5/2 plus 25 over 6, or 40 divided by 6. So this is the mass, whatever unit that is, and then what you're gonna do is, now you, for x bar, you do a double integral of, this time, x times 1 plus y over the region dA, and y bar is going to be double integral of divided by 1 over m, multiplied by 1 over m of y times 1 plus y dA. With the same setup, you still, so m is given here by 40 divided by 6, so you get 6 divided by 40, and the double integral, I still can set it up the same way I set it up for the last problem, and dy dx, and solve. And here also 6 over 40, double integral, this time y plus y squared, dy dx, and I get these value. And what does these value mean is that that's the x value and y value of the point on the lambda, that if you put your finger underneath it, just one little place of rest, the lambda is going to be stable and not rotate in either direction and fall off.